Nuclear energy is one of the most powerful tools humans have ever created, but it comes with a deadly side effect: nuclear waste. Decades of reactors around the world have left behind material so dangerous it can remain radioactive for thousands of years. But what if a tiny startup with cutting-edge technology could solve this problem forever? Welcome to Transmutex, a revolutionary company founded by MIT scientists, and their particle accelerator could finally change the nuclear landscape. On Innovation Corner with Dan, we're taking you inside the science, the technology, and the daring mission that might make nuclear waste a thing of the past. For decades, nuclear power has been a double-edged sword. On one side, it produces massive amounts of carbon-free energy, helping countries fight climate change. On the other, it leaves behind radioactive waste that is extremely difficult to store safely. Traditional solutions involve burying waste deep underground, but this doesn't eliminate the danger. It only isolates it. Transmutex, a startup emerging from MIT, has a radically different idea: transform nuclear waste into something harmless using advanced particle accelerator technology. This isn't science fiction, it's cutting-edge science with real-world implications. Transmutex claims it can reduce the half-life of nuclear waste from thousands of years to mere decades, making storage safer, simpler, and more sustainable. But how does it work? And why should the world care? Let's dive in. The problem with nuclear waste. To understand why Transmutex is so important, we need to understand nuclear waste. When nuclear fuel is used in a reactor, it doesn't just disappear. Uranium and plutonium isotopes break down into a mix of radioactive elements. Some decay quickly, while others remain dangerous for thousands of years. These long-lived isotopes, including plutonium-239 and iodine-129, are particularly troubling. Current disposal methods are primarily focused on containment. Countries around the world store spent nuclear fuel in secure facilities, often deep underground. But these are temporary solutions. The risk of leaks, accidents, or misuse remains, and public opposition to long-term storage continues to grow. The reality is clear: nuclear energy cannot reach its full potential unless we solve the waste problem. Transmutex, a radical solution. Enter Transmutex, a startup that believes the answer lies not in burying nuclear waste, but in fundamentally changing its atomic structure. Their core technology is based on particle acceleration, a method more commonly seen in high-energy physics experiments at places like CERN. In simple terms, particle accelerators shoot high-energy beams at atomic nuclei, causing them to break down or transmute into less dangerous elements. Transmutation isn't new in theory, but it has historically been too expensive or inefficient for large-scale use. What makes Transmutex unique is their approach to scaling this process and integrating it with modern nuclear systems. They aim to take highly radioactive isotopes and bombard them with precise particle beams, effectively accelerating their decay into stable or short-lived isotopes that are far easier to manage. This could mean the difference between storing nuclear waste for thousands of years and safely handling it in decades. A game-changing development for energy production worldwide. How the technology works. The process begins by separating the most problematic isotopes from spent nuclear fuel. These isotopes are then placed in a chamber where they are exposed to a high-energy particle beam generated by a compact particle accelerator. The accelerator sends particles at such high speeds that they collide with atomic nuclei, breaking them apart or triggering reactions that convert them into more stable elements. This process is highly controlled, allowing scientists to target specific isotopes while minimizing unwanted byproducts. One of the most impressive aspects of Transmutex's approach is efficiency. They are designing accelerators that are compact, energy efficient, and potentially scalable for commercial use. Unlike massive multi-kilometer accelerators used in physics experiments, Transmutex's system can operate at the scale needed for nuclear waste management, making it economically feasible. The scale of the challenge. It's easy to underestimate the magnitude of this problem. The United States alone has over 80,000 metric tons of spent nuclear fuel, with similar challenges in Europe, Asia, and other nuclear nations. Traditional storage methods are costly, politically fraught, and logistically complex. If Transmutex succeeds, it could offer a single scalable solution. Nuclear plants could manage their waste on-site, reducing reliance on long-term repositories. Countries hesitant to expand nuclear power due to waste concerns might rethink their energy strategies. The implications aren't just technical, they're geopolitical, environmental, and economic. Why particle acceleration is revolutionary. You might wonder why particle accelerators are suddenly the key to solving nuclear waste. The answer lies in precision and control. Chemical or thermal methods can't alter atomic nuclei in the way accelerators can. By using high-energy beams, Transmutex can selectively target isotopes that are the most dangerous, drastically reducing the volume and toxicity of waste. This technology also opens doors for innovation in nuclear energy itself. If reactors can be paired with transmutation systems, we could imagine a future where nuclear power is not only clean, but also produces little to no long-term waste. This would eliminate one of the biggest environmental and political barriers to nuclear expansion. The economics and feasibility critics have long argued that particle accelerators are too expensive for practical nuclear waste management. Traditional accelerators require massive infrastructure and enormous power consumption. Transmutex is challenging that notion with miniaturized, highly efficient designs. By combining advanced materials, modern electronics, and AI-driven beam control, they aim to make the system cost-effective for commercial use. If successful, this could lower the cost of nuclear energy even further, as waste management is a significant portion of total nuclear expenses. Investors are already taking notice. The potential for both environmental impact and economic return is enormous, and backing from venture capital and tech leaders signals confidence in the feasibility of the technology. Challenges and skepticism. Of course, there are significant hurdles. The technology is still in development, and scaling from laboratory experiments to industrial-scale operation is never easy. Particle accelerators require precise calibration, high-quality materials, and rigorous safety protocols. Any error could compromise the process or create unexpected radioactive byproducts. Regulatory approval is another barrier. Nuclear waste management is tightly controlled, and authorities will demand extensive testing, safety validation, and risk assessment before deploying this technology commercially. Public perception is also critical. While particle accelerators are generally safe, nuclear waste is an emotional and political issue that draws intense scrutiny. Global implications. If Transmutex succeeds, the global impact would be profound. Countries hesitant to invest in nuclear power due to waste concerns might adopt this technology, helping reduce reliance on fossil fuels. International collaboration could also accelerate the development of advanced nuclear energy, as waste management becomes less of a bottleneck. For developing countries, compact and scalable transmutation systems could provide a pathway to safe nuclear energy without decades-long storage challenges. This could democratize access to high-quality electricity while maintaining environmental safety. We recognize that this is exactly the type of breakthrough with potential ripple effects across energy, technology, and climate policy. Solving nuclear waste is not just about cleaning up old fuel, it's about opening the door to a cleaner, safer, and more reliable energy future. The future of nuclear energy. Imagine a world where nuclear power is truly sustainable. Nuclear plants could operate without creating waste that lasts thousands of years. Governments could invest in energy infrastructure without fearing political backlash over waste storage. This vision is not just appealing, it may be necessary as the world confronts climate change, rising energy demand, and the limits of fossil fuels. Transmutex's particle accelerator could serve as the bridge between today's nuclear technology and a cleaner, safer, and more advanced future. It's a reminder that some of the most transformative innovations come from thinking differently about old problems. The journey to solving nuclear waste is far from over, but Transmutex is a bold step in the right direction. Their particle accelerator technology could redefine nuclear energy, transforming a centuries-old problem into a manageable solution. We celebrate innovation that pushes the boundaries of possibility, challenges conventional wisdom, and addresses the critical problems of our time. Transmutex is a perfect example of that spirit, a tiny startup with an ambitious goal that could reshape how the world thinks about energy, waste, and sustainability. The nuclear future is complex, but with ideas like this, It's also exciting, hopeful, and full of potential.